Alright, there's a lot of equipment here, and I wanted to make a short and concise video explaining why I did what I did and the different options. So what we're doing is we're taking a 30 amp coach with a 12 volt 2000 watt inverter that is connected up to the alternator, and we're adding to this coach a mini split. The high energy efficiency mini splits operate off 230 volts, whereas in everything in every RV is 120. So how do you solve this? Easiest way to do that is to actually just take something like this transformer right here and add this to the output. It's going to basically take 120 volts from the inverter and it's going to give you 240 out. So this way, the mini split consumes around 1600 watts. So you can run that mini split and the TV with no problems from the 2000 watt inverter. You can get yourself a little transfer switch. As soon as you click on the microwave, it'll turn the air conditioner off, the microwave will run, and then when it's done running, it'll turn the air conditioner back on, because you don't really have enough power to do both, but you can have a little automated system like that. So that's the first option. If you're looking to go a little bit bigger, what you can do is you can actually get yourself another 12 volt inverter, something like the Victron Multi Plus 3000. Now the way that I would wire that up is on the coach from the factory, there's an L2 and an L1. The L2 takes the input from the generator or shore, and it does two things with it. First off, it sends it to the rooftop air conditioner, and the other thing it does is it sends it into the Xantrex inverter, which then sends its output to the L1. I would have the output of my Multiplus feeding into that L2 side and taking the power from the generator and shore, so that I'd be able to use both of those together. And the way that I would probably do that is I would probably have the transformer hooked up to this, so that this could take anywhere between 40 watts and 1600. So I'll be able to get one or two appliances running from this, and definitely one appliance running from the 12 volt version, or the 2000 watt inverter. So that'd be a pretty good option right there. So I'd be able to have an L1 and an L2 and run two simultaneous kitchen appliances and the mini split without any issues. And if the mini split was consuming a low amount of power, then I'd be able to run three appliances simultaneously, all in the 12 volt system, and that's a pretty good setup. So that's one of the things that I could have done. The next step up from the 12 volt system is to have a dual battery system. We're going to go with a 48 volt battery, and we're still going to keep the existing 12 volt battery system as a backup. And in this case, we're going to go with a 48 volt 3000 watt inverter, and it's going to be configured just the same way that the Victron Multiplus was, with this feeding the L2 side and this feeding the L1 side, and with this feeding the transformer. So that's definitely an option that you can go with. As the 48 volt version of this, regardless of brand, is going to be able to send the full 3000 watts from the onboard generator, or the maximum of the 30 amp power connection, into the battery. And that's one of the things we were looking for, was to not be recharging that battery at 1200 watts, but the full maximum power of 3600 watts if the generator can handle it. After some testing, I settled on running this at 80% power, which is 3000 watts exactly. Trying to push it to that high actually overloads the breakers. The 30 amp breakers on there, after about 30 minutes, get too hot and they'll trip. Even though I've dialed it in to be like 29 amps or 28 amps, doesn't matter, it still overheats and flips off. But dialing it down to 80%, which is 25 amps, I think, is perfect. And that works absolutely flawlessly well in terms of the power going into the system, and because it maxes out the factory generator, and that's a really good option. And then whenever this runs the primary appliances, and then whenever this turns off, the 12 volt battery exists to run like the lights and the fans and the refrigerator. So That's a pretty good option. And if you wanted to, you could always just manually click that thing on and microwave something and then turn it back off again, kind of more or less the way it is from the factory. Because we're going to be saving a good bit of that 12 volt battery power to make sure the refrigerator stays running. Because if you're got a full refrigerator full of whole food stuff, then this system turning off and coming home to a full refrigerator of spoiled groceries is really annoying and really expensive. So holding on to that extra power is a really, really nice option with a dual battery system, because that allows you to just keep the air conditioner on all the time and run it all the way down to zero. You're never leaving something behind, and then you have this full backup system that's always 100% charged, so you never really have to worry about how much time you have for the refrigerator, and that gives you that extra peace of mind. And it also gives you the opportunity that you can kind of run like a laptop or a TV or some other kind of equipment as well, even though the primary system's off, and it'll automatically get charged again once you turn on the generator or solar starts to hit it. Now the next option we could do is we can actually get rid of this transformer here and replace it with a 230 volt inverter that either runs off of the 48 volt battery or off of the 12 volt battery. And that way we have a dedicated inverter that will just run 24/7, or at least as long as the mini split does. And this is just a dedicated mini split inverter. It really doesn't do anything else. And that's one of the options that you could do for this system. Particularly if the price point between these two is close, and the weight is also really close. This is actually, while it is smaller physically, it is actually heavier. This is about 30 pounds to about 20 pounds for this guy here. But this adds a couple other nice features like a solar controller and the ability to also take AC power input. So this can take the 230 volt AC input from a 50 amp RV port, and in that case you can actually up your charging level from the base of 3,000 watts to now you can do a 5,000 watt charge, and that's kind of nice. So that would be the option to add this to the system instead of having this. Or you could actually just get rid of this inverter right here entirely, and you're just going to have the 5,000 watt 230 volt inverter connected up to the transformer. So then you're going to have your 230 volts here. It's going to turn into split phase. So you're going to have 2,500 on L1 and L2. The L1 is going to feed into that, and the L2 will feed into the other side, kind of replacing what that charged, and should be more, in terms of what you're actually really able to run, not much of a difference. So this is your 230 and your 120, and the only downside of this is that you don't actually have a 120 volt input method. It only is going to take 240, so you'd have to be plugged into a split phase, unless you wanted to actually get yourself a midpoint transformer like this one here, and then actually run your 120 into this. The 120 will give you 240, which will flow into here. But unfortunately now we're either sharing one input output device, or we have to buy two of those, so it doesn't really work to go with that method there. But each of these have their own pros and cons, and it all depends what you're using it for and how it's designed. So let's get rid of both of the transformers. The way that we'd hook this system up is we're just going to have two 120 volt inverters combined together into split phase. That's going to give us our 240 volt output for the air conditioner directly from these inverters. No transformer required, and it's also going to give us 120 to the L1 and the L2. So that's 3,000 on L2 and 3,000 on L1. That's a 6,000 watt system, minus whatever the air conditioner is using. So that's not a bad way to design it. However, the problem to that is the only way you can actually charge from a system like that is if you're going to hook it up to a 240 split phase input. So The way to get around that is to add a transformer, so you can take your 120 input from your generator, flip it to 240, and then send it into the system as a split phase. So that's the other option that you can do in terms of getting this to run. Now, that was the option that I had actually built out, but I was having difficulties with a few technical issues with that, so I ended up doing the following design. When I'm connected to an electric vehicle charge adapter, I can actually pull the maximum power from that charger, which is 6.6 kilowatts or 6,600 watts. In fact, it was exceptionally easy to overload that, because if I'm putting 5,000 watts into the battery from this, and then I'm also going to put, 500 watts into the air conditioner, that only leaves me with, I'm now at 5,500 watts. If I try to run something like the microwave at 1,800 watts, I've now put myself over I'm at 60. I'm now over the 6,600 watts, and I've overloaded that charger, and that was one of the problems that I kept running into, was just constantly overloading the system. And while you could sit there and kind of dial it back, if you're sitting in a Whole Foods and you're plugged into the EV charger, you want to pull that full maximum rate from the system. But since I'm also sitting at a grocery store with nothing to do for an hour or two, I want to cook. And I can't really cook that. I can't really cook at the same time, because if this is pulling in 5,000 watts, and I have the oven running, so the air conditioner is pulling another 1,000. That only gives me 600 watts left over for power. So I could use the power assist feature or power boost, and basically just kind of start reducing the charge rate, and then taking that power and sending it out to the devices. However, there was a limit to that. Once I was hitting around 3,000 to 4,000 watts of power, which is just, like a microwave and a coffee maker, or a microwave and a blender at the same time, or the air fryer and the something else. The power assist wasn't being reliable, and I was pulling too much power and overloading it. And that overload potential is so annoying, because you have to stop everything you're doing and reset everything. And it didn't happen all the time, but it happened enough that I decided to spend a lot of time and redesign the system from the initial split phase design into this system. So the solution for that is that as soon as this thing is getting maxed out, it automatically switches over to this system right here, and this thing kicks on. So this is going to give you your full 3,000 watts of output power to run your appliances. And then if you want to, you can choose to disable this output and actually just pull it from your 12 volt system if you really wanted to. So you have the options and the flexibility to do it that way. Because when you are sitting there and you're pulling that power, I wanted to also be able to use 2 simultaneous kitchen appliances, and then also top off my 12 volt battery. So that's why everything is wired up that way, because you're going to be there for 2 hours, and I figured I might as well get my cooking done. So I might be pulling 6,000 watts from that outlet, but I might be using 3,000 for the 20 or 30 minutes it takes for me to cook up my food. And I just couldn't get the power assist feature to give me that reliably, so that was the solution that I ended up going with for that fact. And when I had the split phase system, I had some trouble getting everything to balance out right, because the mini split was kind of stealing parts equally from it, and then that was giving you 2,500 watts and 3,000 and 3,000. And then when you're taking that down to 2,500, that was kind of just giving me one appliance per side. Because most of my appliances are kind of bigger appliances that pull 1,800 watts or 1,500 watts, and I'm not getting anywhere with them. With only 2,500 watts, I'm not getting 2 simultaneous power appliances, so I really wasn't getting much of a difference in terms of the actual output of the system. And with the way that I have this configured is I actually have this right here is sending the 240 out to the system, and then I'm still retaining the L2. So I have the full, if this is pulling 1,000 watts, I have 2,500 watts on my L2 plus 3,000 watts on my L1, so I have a total of 5,500 watts available inside the coach for me to use while I'm charging at a 5,000 watt rate and running the AC at max, 1,600 watts. So it's the combination of all of that power that is the reason that I did this the way it was, because to have 3 devices on at the same time is really, really nice and eliminates any kind of restrictions that I would have, because especially when you kind of treat it like a home, like I'm going to sit there and I'm going to cook, I'm going to like start all the appliances at the same time, and if my wife wants to go and blow dry her hair, we don't have to worry about her blowing the overloading the system, because there's a 20 amp in the bathroom, and then there's an extra 20 amp in the above the kitchen, and then we have the factory 3,000 watt system. So you can have 3 or 4 appliances using that 5,500 watts of power, and that's really quite nice. That eliminates all of the difficulties and gives you the same feeling as a 50 amp coach, but it's still just wired for a 30 amp coach. And even though this complicated mess here did take me a bit of time to describe, now that I've written it down and tested it, I could recreate this very quickly. And that's the reason why I settled with this design here, because I wanted to have the full 50 amp coach experience without any limitations, and this gives it to me. This also allows me to have the option to actually kind of rewire the stuff on the fly, and that's one of the coolest things, because not only does all this stuff not need to function for it to work kind of from the generator, but you can actually just take power directly from the alternator and send it into the Xantrex, and then from the Xantrex there's a little bypass switch, this guy right here. And then you could use that and then directly power this transformer and then send the transformer power out to the mini split. So even with the entire 48 volt battery system unavailable and with no propane for the generator, you can still run the air conditioner off of engine power. And that was kind of a really, really nice option to get with this. And it's a quick rewire. So I ended up going with that option because it's very, very flexible, and it means that you can eliminate any one of these pieces of equipment and still have full functionality. Even if the 48 volt battery doesn't work, you still have the 12 volt. If the 12 volt doesn't work, you have the 48. They both feed and charge into each other as well through automated and manual controls. So it's very, very flexible. And more importantly, it doesn't require the user to really do anything. You just let it do its thing, and occasionally you might want to turn something on or off according to what it is. But that's the reason that I went with this system, was the amazing output power and kind of that flexibility for redundancy. But there's a lot of different options that I could have gone with, and if the generator was 5,000 watts instead of 3,600, if it was a 50 amp coach instead of a 30 amp coach, anytime you change up what you're doing here, obviously I would have picked a different equipment, a different configuration option, but I just figured this explanation kind of shows all the different ways that you could do this. And depending on your configuration and your parts and the space available to you, none of those decisions is really wrong. It's just a different way to do it. I really like the way that this works, and I think this is amazingly flexible because I've been able to run both of these systems at max power, and they don't overload, they don't trip breakers, and there's really no way to break it. You're not going to be... I mean, I suppose you could try to run 5 simultaneous appliances in a little 24-foot coach, but that's a bit overkill. But having that amazing level of power is really nice. Additionally, it also allows you to take the full output of this guy right here and actually send it to a residential home, and then use the 2,000 watts to power the coach, and then the 3,000 watts to power another coach, because they're all wired up independently with 30 amp RV plugs. So you could actually run like a house, another camper, and yourself all together, with no reconfiguration or wiring or anything. You just go in there and grab the little labeled connector and plug it in. Super duper simple. And that's the reason that I went with this, is it has the most flexibility and configuration without being unnecessarily complicated or having any possibilities to where you'd have to plug things in or move things around or kind of do anything like that. This configuration where you'd be powering 3 separate things is really kind of weird. And the way that it's set up, we really actually don't need to unplug anything, assuming you have a 20 amp external plug-in for a van outside, and then that runs off of that guy, and then you have the 50 amp which runs off this guy, and then the coach on the inside will run off of this guy. So it actually all works out. And that's just with the default plugs, but you can, like I mentioned, take it apart and kind of reconfigure it, because underneath the paneling is actually just plugs. So that's all I got to say about that, and kind of why I did the way I did it.